Alright, last video of the year, Unit 11. This should say Systems of Equations and Inequalities. Sorry about the misprint. Whenever you solve a system of linear equations, there are three possible answers that you might get. You could get one solution, and that's where if you graph the equations, the lines are going to intersect one time. You could get no solution, in which case the lines are parallel. Or you could get infinitely many solutions, in which case the lines are like right on top of each other or overlapping. Okay? There are three methods that you can use to solve a system of linear equations. You could graph it either by hand or on a calculator. If you do it on a calculator, you could use the function intersect to find the point of intersection, if there is one. If you substitute, hopefully you guys remember that when you substitute, you basically solve for one of the variables in one equation, and then substitute that into the other equation and solve. Once you get an answer, a number answer, you plug your answer into either equation to solve for the other variable. When you use elimination, you're going to want to multiply one or both equations by some constant so that either both x's or both y's have the same coefficients. Then you're going to want to line up the equations and either add or subtract vertically to eliminate a variable. And then solve the resulting equation. Once you get a number answer, plug your answer into the other equation, or into either equation to solve for the other variable. I don't know if you guys have experience working with matrices. If you don't, that's okay. Go ahead and copy down these row operations and the steps to convert to row echelon form. It's not really going to make sense unless I do an example. We will be doing examples in class, so for now just copy them down and read them over. Okay? Alright, determinants. There is a way to find determinants on your calculator, and I probably should have had a how to find a determinant on your calculator list, but I guess it slipped my mind. This is how you would find determinants by hand. Okay, and I will do examples of this in class, so go ahead and just copy this down for now. Determinants are useful for a number of things. One thing you can use them for is called Cramer's rule. If you have a 2x2, or if you have a matrix of two equations containing two variables, you can use these equations to solve for x and y, instead of just solving for x and y. Okay? If you have three equations containing three variables, it's pretty much the same thing. I didn't want to write out each determinant or matrix of the determinant matrix for each of these because it would take up too much space, but basically D is the regular determinant of the matrix. D, X, Y, and Z is the determinant where the C's replace either the X, Y, or Z column, depending on which variable you're talking about. Okay. If you add or subtract two matrices, you're just going to add or subtract the corresponding terms in each matrix. If you multiply a matrix by a constant, then you just multiply each term in the matrix by that constant. The inverse of a matrix, if you multiply a matrix by its inverse, either way, you're going to get the identity matrix. The identity matrix is basically a diagonal of ones with zeros everywhere else. Okay? Matrix multiplication is a little bit more complicated. If A is m by r, then B must be r by n. In other words, to find the product AB, the number of columns in A must equal the number of rows in B. Because of this, A times B does not necessarily equal B times A when we're talking about matrices. Alright, I gave a very small example. If you were to multiply this matrix, this 2x2 matrix, by this 2x2 matrix, it would be A times E plus B times G, so the first row and the first column, and that would give you the first term in row 1, column 1. Then you would do A times F plus A times H, and that would give you first row, column 2. And then same thing with the next row. So basically, each place is going to be the row of the first term and the column of the second term. Okay? And that pattern works for any matrix, no matter how big. Okay? This is the procedure for finding the inverse of a matrix. And once again, it's not really going to make too much sense unless we do an example. We will do some examples in class, so go ahead and just copy this down. If a matrix has no inverse, basically when you try to do these steps, you're going to find that it does not result in the identity matrix that it's supposed to. The identity matrix looks like this. It's basically a diagonal of 1s with 0s everywhere else. Okay? Decomposing a rational expression into a sum of partial fractions is important in solving certain types of calculus problems. There are 4 different cases you need to consider when decomposing during partial fraction decomposition. Go ahead and write this down. It's, once again, I really don't think it'll even if I were to go through and explain everything, I think you guys really need to see an example. So just copy it down and we will do some examples of this in class. Okay? When graphing an inequality by hand, you know what? I just realized I misspelled though. Give me just a sec. There we go. You want to graph it as though it had an equal sign. So whatever the inequality symbol is, just graph it as though it was an equal sign instead. Then you're going to want to plug in a point on one side or the other of the graph that you have, and then shade accordingly. Basically, if the point you chose satisfies the equation, you shade the side with the point. If it doesn't satisfy the equation, you shade the other side. Okay? Also, hopefully you guys remember, I don't know what happened here either. That's right. Hopefully you guys remember that if you have inequality symbols like, here, let me pick a different color. If you have this or this, you get a dotted line. If you have this or this, you get a solid line. And when graphing on a calculator, I don't think the TI-83s actually have the function that allows you to shade. If it does, I'm not sure how to do it. So basically you would just graph the regular equation as though it had an equal sign, and then you would proceed just as though you were graphing it by hand. So there isn't too much difference graphing by calculator or by hand. And that's all for Unit 11.